And hello, everybody. Welcome to this Wednesday for the Intro to Cassandra for Developers, one of our cloud native workshops. And I am joined today with Erick ZIETLOW. Hello, Erick.
Hello.
Hello,
yeah, so this is going to be not the continuation of that big series we just finished. So if you went through that, this is maybe not the right session for you. This is more the super intro. I've never touched Cassandra before. I want to learn how to start developing on it. This is for that crowd. So just to kind of level set, make sure we're not, wasting anyone's time or anything. If you have never touched Cassandra before, or maybe you touched it 15 years ago, actually it wasn't around 15 years ago.
Yeah, it wasn't around 15 years ago.
Right.
If you touch it when it was still using Thrift, right, back in the day.
Right. Exactly. This is probably something that crowd is going to get a lot of benefit from. So just kind of understanding what it is we're delivering here today. All right. Well, should we jump right into it?
Why not? I mean, what do you... we could just wait for everybody to say thumbs up or something, but I think we can just go. I think we can do it. Let's do it.
All right. So, I am part of the developer advocate team. Again, Erick ZIETLOW. I am a US-based developer advocate. David is another US-based advocate. We also have a more global team here today. If everyone who's on the team can say hi in chat there in YouTube, that would be awesome. We've got just a wonderful group of people. We got Bettina, I think she's here. We got Erick RAMIREZ, who's here sometimes as well. Alex, who's our, shall we say, Russian-German counterpart. And then, of course, Cedric, who you guys have probably seen. If you've ever watched our streams before, you've probably seen him a couple times. And then Patrick, but we don't talk about Patrick because he's the boss, or what? It was the boss.
You can't talk. Nobody talks about. Nobody puts Patrick in the corner.
Yeah,
no one puts Patrick.
Totally not important. All right. Today we're going to need a few things. We're going to be using a few things. First off, if you have questions, feel free to drop them in the YouTube chat, or if you want to actually connect with us on a slightly deeper level, we do have a Discord server that you guys can feel free to connect to, ask questions, interact. Just a great place to actually get questions answered, and we do check it throughout the week. Even when sessions aren't active, we'll oftentimes just go and kind of peruse what people are discussing on there, and throw in 2 cents here and there, answer some questions. Really good place to get connected. The other things you're going to need for today on your end, other than a web browser and a laptop, on your phone, I would highly recommend you guys go out and download something called Mentimeter. It's an app. I believe it's on the Google Play Store and the Apple Store. We're going to be using that for our quizzes today.
And if you don't want to download it as well, the links we provide and the QR code, it'll just bring you right to a web page that you can use. So
Yes. If you don't want to download it, but that's all going to be done from your phone. So just keep that in mind here. We are going to be utilizing DataStax Astra. So this is Intro to Cassandra for Developers, using Astra. So Astra is basically self-service Cassandra. We'll get into that a little bit more. And then, of course, YouTube or Twitch, whichever platform you do happen to be watching us on, that is obviously a kind of a requirement here. All right. So a couple things to point out. We do have a community site. This is a place where you can get basically 24/7 feedback, input, engagement, just with other Cassandra users, with us, with just kind of a wider community. If you have questions, if you just want to discuss a topic, if you have ideas, go check it out, make posts, and get involved in the community. It helps everyone the more people are engaged there. So please check it out. Training, we also have a academy.datastax.com where we're providing a lot of training these days. That's going to be slightly different content than we're getting here. It's mostly self-service type content. A lot of it's actually moving over to kind of a Katacoda. If anyone here has used Katacoda in the past, it's kind of a way to do a lot of lab type homework, but online without having to download VMs or set up a cloud instance or anything like that. A really easy way to get engaged and get started. All right. I already mentioned Discord, so I'm just going to leave that one there. All right, so what is Astra? Astra is just a fully managed Cassandra. So basically taking all of the operations difficulty out of the equation, just giving you something where you can say, I need a Cassandra cluster, I need it to have these attributes, go. And you click a button, it spins up, and you can almost, within a couple minutes, you can start submitting queries and getting data back and putting data in and seeing actionable results. Now, anyone who may have been at one of our workshops way back in the day before Astra existed probably remembers that about half the day was spent setting up Cassandra. This completely eliminates the need for that.
Yeah, especially, and just to kind of add to that, Cassandra or Astra was purpose-built really for developers, with developers in mind. Because as developer advocates, we're all coders. We're all, even though we happen to be in this database world, we're all folks who have developed real-world applications. And even for those of us who like databases and who have been working on them for years, a lot of times when we're developing our applications, we don't want to have to worry about managing all of that extra load on top of getting our application. It's more about, let's get the application up, let's hook up to the database and go. That's what Astra's for, and that's why having this service that essentially is, Cassandra managed for you and allows you to kind of get spun up and going in a couple of minutes is just so cool from the developer perspective.
Absolutely. And to your earlier point, who doesn't like databases?
I love databases myself, but
Yeah, absolutely. All right, so Astra does have most of the same, it's Cassandra under the hood. So the benefits you'd expect from Cassandra are there. So global scale, all of those kind of taglines that are Cassandra's big selling points all exist in Astra. And that's a good thing. That's what we want to take advantage of. That's one of the reasons why we would use Astra. There are no operations. So that's a huge benefit because operations, that's not what developers are generally here for. That's not what I, as a developer, if I'm actually trying to go out and make an app, I don't want to spend 3 weeks spinning up a cluster, getting it configured, getting all the boxes configured. I just want to be able to click a button and start development. Time to hello world is important to me. And then we are going to be using a free tier of Astra. It's a free forever, 10 gigs of storage. So it's a very small instance, but it's a free forever. And we're going to do some labs on that today. Okay. So we talked about Menti. This is the first Mentimeter. This is mostly just so you guys can get set up with the app, feel comfortable. That way when we do the actual quizzes that have kind of prizes or things associated with them, you guys can be ready to go on those. So I'm going to hand it off here to David, and he'll walk you through it.
Yeah, and if you would, before I get to grab it and change the screen on my side, but if you would, you see we have a QR code there. I see some folks are already in Menti. Wonderful. So you can scan that QR code on most phones with your camera, right? That'll bring you right to the link. If not, I'm going to drop in the chats. You go to menti.com and you put in the code 8422830. Let me grab this and put it over here as well. So you could do it either way. So just scan the QR code or go to menti.com at that code. You'll see it up here on the screen in a moment. And what I'm looking for is if once you get into the Menti, you will be presented with, you should see a little screen, little thumbs up. Give me a thumbs up. Let me know that you are there. And I will wait just a little bit for folks to move forward. Okay, I just flipped over. Right, you should see some thumbs up happening.
I'm going to do this along with you guys.
Yeah. Oh, and somebody was asking for the Discord link. Thank you, Alex. Let me drop that Discord link as well for those of you who are on YouTube. Discord. There you go. And that way you have that wonderful... All right, let's see, how many folks do we have over here? And I'll just give it a moment. Now, the important thing about Menti, as Eric just mentioned, we are going to ask you some initial questions here, really more from a survey perspective, help us understand you, the audience, and who's attending and everything. But you want to leave this open, because then later on, we're going to have a quiz. And the top 3 winners of that quiz will then get some swag, right? So it's important that you leave that open. All right, so let's go ahead and move into the survey. So this is just a set of questions, real easy. This isn't the quiz yet. We're just trying to find out, who do we have here? All right, so first one is, how much experience do you have with Apache Cassandra? Let some of those come in. All right, so it looks like most of you have never used it before. That's wonderful, honestly.
That's perfect.
Not that for the folks who have used it and have some experience. I see we have some veterans in here. Not that that's bad or anything that you're here, but obviously for a workshop like this, we tailor the content more to those folks who have very low usage of it. So wonderful. Thank you for that. All right, next one. Have you been to any of our workshops before? Okay, so most of you know, but we have some repeat offenders. I mean, some... Well, for those who have been here before, for the 16 I see that say yes, thanks for coming back. Hopefully you'll get something different out of this or new out of this from what we've done before. And for those of you who have not been to one of our workshops, welcome. Welcome, to your first experience here. All right, next one. Thank you, everybody, for that. What is your main motivation for learning about Cassandra? I'm laughing at VS. He says, wow, I have 5 browser windows open for this workshop. I might actually learn something versus the 50 I usually have open. I have so many tabs open at any given time, that is for sure. Okay, so let's see. We have a kind of an interesting split here, right? That we have some folks that are interested in learning for both dev and admin, and then some that are really interested in developing specifically for Cassandra, and then just some that are specifically looking for administration.
Right. It is interesting to point out, so this particular course is not going to be at all admin focused.
Yeah.
Doesn't mean there's no benefit for you, though.
Right.
Understanding how the system is used and developed against is always a good thing for an admin to do. So there's definitely still some benefit, but we are not going to get into anything deep on admin topics.
I mean, you can always ask questions, but yeah, to Eric's point.
Yeah, absolutely. Yeah. And if we have time at the end, we might do an AMA or something to help you guys out, field some questions.
Oh, totally. All right, next one. And finally, how did you hear about this workshop? Yeah, this is always so curious to find out how folks got here.
Yeah, Eventbrite seems to be a pretty big thing at a lot of these.
Oh, from Instagram, which we don't have up there. I see it. Yeah, I'll make sure we get that on another one. I'm actually... I didn't know we were promoting out on Instagram. That's really interesting. I got to find out about that one. Of course, I'm not the one who's doing that. From Facebook, some from Facebook as well. Okay. All right. Seems like I've got some that I need to add in there.
Yeah.
Yeah, LinkedIn. Okay. All right. Excellent. All right. Last one here. What do you want to do with your new knowledge?
Okay.
Alrighty. Yeah, and one thing we are definitely seeing, and obviously why we put some of these on here is, especially with all the things that are going on right now, we're seeing a big influx of folks that are definitely looking to get a better job or get a new job or whatever. This is definitely more geared towards, for developers, and that's kind of why we've presented it this way. From the understanding standpoint, for those of you who may have experienced some Cassandra before, or if you haven't, right, we're going to just jump right into, creating tables, doing CRUD operations and everything. So hopefully, again, this is going to get you that initial primer to get going and start working with Cassandra. All right, wonderful. Thank you so much. And with that, please keep this Menti window open, because then what will happen is when we go to do the quizzes later, we'll come right back here, and we'll be all set and ready to go. All right, so with that, I'm going to flip it back over to Mr. Eric. Boom!
All right.
You have the con. You have the con.
Awesome. Well, that brings us right into our first exercise. So right off the bat, we're going to get our hands dirty here. And this is kind of a preparation one. So can I get someone to throw the GitHub link into chat there, David? Would you handle that? So everyone, go to this GitHub. This GitHub has everything you will need to do the labs. So if you want to do them later, if you want to do them along with us, this is a fully self-contained set of labs that you can do that basically we'll run through here today. So we got a table of contents, which is kind of our 3 assignments. We're going to go through assignment 1, which is literally we're just going to spin up a database on Astra. So something we can actually run commands against, something we can actually use today. So go ahead and go to astra.datastacks.com. And that should get you to a window that looks something like this. And go ahead and either create an account if you don't have one, or sign in if you do. And then I'll give you all a moment here to do that. And then we will jump to the next step here. So just give you about a minute. All right. And once you are in, you will have a window that looks something like this. So, first thing we're going to do is, we've got a lot of instance types. Today we're going to use the free tier. Again, that's important. 10 gigs of storage. Yes. You don't need to put in a credit card or anything to use the free tier. It's just click it and we'll go. So, go ahead and click free tier. For region, if you're in the US, I highly recommend using US East. If you're not, if you're over more towards Europe, there is also a region over in Europe. I believe it's, Europe West. So select the one that's relevant to you. Then we're going to get over here to database name. Now you'll notice, if we scroll down a little bit, we actually tell you exactly what to fill in all of these fields. So database name, for example, is Killer Video Cluster. So I'm going to go ahead.
And just something to point out, if if you're not able to follow exactly with Eric as he's doing this, we're going to give you a couple minutes to go do this on your own once Eric brings you through this real fast. So don't think we're just all right, go.
Absolutely. Yeah, we don't want to leave anyone behind here. Okay, so key space name is going to be Killer Video. We'll get into what a key space is in a few minutes, but just for now, we'll use that name. KV user is going to be our user. That is what we use to actually access the database. So if we were setting up a driver or something, that is the username that the database the driver would use to talk to the database. And then, of course, KV password being our password. We're super secure. And then confirm our password. Don't use those values in production, please. But for today's lab, that's what we're sticking with. So then go ahead and just click Launch Database. Give that a moment here. It says launching our database. Now this can take between, generally it's around 2 minutes. Sometimes it's even less. But it can take as long as about 10 minutes, depending. And since, how many do we have in chat there, David?
Let me see. That is a good question. Let me find out. I gotta open up my window for it to tell me.
If it's more than a couple hundred, it might take, we're all hitting the same servers at the same time, so it might take it a few more minutes.
Well, and once, the key thing is just to get to the launch database piece, and then if you, I know, Eric, you already have one, so you're probably not going to launch it.
No, I started fresh for this.
Oh, did you really? Oh, okay. So once you hit the launch, then you should see a screen just like what Eric is showing you now, right? Where you see that green bar at the top, it's going to say, hey, I'm building this database. It might take a couple minutes, again, as Eric mentioned, because we have a bunch of people doing it at once.
So that was
fast. Yeah, boom.
That was a minute
Wonderful.
And a half. Yeah. So as soon as you get to this window, you're good, and we will move on with the content. So I'm going to give you guys probably about 2 minutes to get your account all good to go. Let me start a timer here.
Yeah. And just so you know, so Bettina made a good point in the Discord. She said if you use the suggested terms for user, password, and key spaces Eric suggested, it will be easier to follow along. So just as a point of clarification, in general, it's not like you have to use some hard-coded values for these to use Astra. For the purposes of the exercises and to go through the materials and what we've done, it's just much easier if everybody's using the same thing. So then if someone does run into any kind of snag or troubleshooting or something, we know what answer to give, right?
Right.
So
and
just to
all
make
of
that
our
clarification.
stuff, all of our commands down the road are going to be configured. They're all set up using those values. So if you do use something different, it's going to be a little bit harder to follow along, for sure. But
Yeah.
we'll give it about another minute here, and then we will move on.
Okay.
All right, half a minute. If you guys would be willing, just put a thumbs up in chat there when you're at that page, and we can kind of see if a lot of people are hitting it or not. All right. Ooh, that is really loud.
Oh yeah, I always stop it before that alarm goes off.
Right.
Yeah,
Right.
and for those that are still initializing, it's totally good. The key thing, and if Eric, if you could go back to the yours already formed, but it's in the repo.
Right.
You'll see an image where you'll have that green bar. It might take a couple minutes to initialize.
Right.
As long as you're there, you're good. We're gonna move on. Eric's gonna get into some content. By the time we come back, you should be good to go.
Right. Okay, so going back to our presentation here. All right, so hopefully you guys all got there, or at least you're well on the way to getting there, and we can let that spin up while I go through this next section. All right, so 3 things we're going to cover today. We're going to cover what tables and partitions are, so how your data is actually stored, and then we're going to talk about the art of data modeling, or how to use the tables and partitions to store your data in a performant manner. And then, of course, what's next, which is kind of wrap up for today. So tables and partitions is what we're going through first. All right, so a couple definitions here real quick. A cell is exactly what you'd think it is. If you used any more traditional database, rows, columns, and cells all exist in Cassandra. So when I do a select statement, I'm returning rows and cells basically. So understand that one. A row again it's just a collection of cells that go together. It's structured data item, a single structured data item in a table. Then we have this thing called a partition. Now this is where it starts getting a little maybe diverging from anyone's knowledge who was part of the SQL world. Partitions are a single unit of like data. And what that means is when we, since Cassandra is a distributed system, it actually chops up your data and stores it in a lot of different places across a lot of different machines. The partition is the smallest chunk it will chop something into. So it chops everything down into partitions and then distributes those partitions across machines. So those partitions are all similar data, and we control that with something called a partition key, which we'll get into. But just for now, understand that a partition is a group of one or more rows that all go together. Okay, a table is a group of all the rows that are within the table. So a grouping of like tables in a much more broad manner than what a partition does. So it's a grouping of partitions, you can think of it as. So every partition that goes in a table, fills it out, makes the table. All right. So our overall structure is we have these partitions. Those partitions have this thing called a partition key, which we'll get deep into. I'm not going to go too deep here because for the sake of time, but we'll get deep into that in a few minutes. That partition key defines the partitions. Those partitions are made up of rows and columns, and they make all the partitions together make the table. The table sits in a key space. Now you'll remember one of the parameters that we typed into the box there, I think it was Killer Video was the one we used, was a key space thing. That key space is literally just a bucket for tables. So if you've used another database in the past, for example, like a MySQL or an Oracle or a Postgres, the keyword of database or schema is very, very similar to what keyspace is, just functionally. There is some nuance with Cassandra, but we're on Astra. We don't have to worry about any of the operational differences. Essentially, just think of it as a bucket you store your tables in. Okay. So, partitions. Now, this one we really need to understand. This is the kind of the meat and potatoes of the entire day. Once you got this, great, we can all go home. Well, so partitions, I said, are groups of like data, right? So they are defined by that partition key column there at the bottom. You'll notice we have a few rows of data there. We have, what, 6 rows of data? We have 2 different partition keys. The partition keys for Phoenix are all the same. And all of those things in the Phoenix partition key are part of the same partition. They live in the same place within the database. They're referenceable by that partition key. Next, we have clustering columns. Now, clustering columns are how you order things within a partition. So if you think about it, the partition key is how you distribute the data. The clustering columns are how you order the data within that distribution. So we have a last name, ordering of data. Then we have our data columns. And data columns are nothing special. All they are is basically payload. They are data that you are trying to get back, and the partition key and the clustering columns provide you the address to retrieve that data. And of course, as we mentioned before, rows are living in the partitions. So, okay, what this looks like. This statement should actually look really, really similar to any sort of create table statement you've worked with in most other databases. The key differences here, so we notice right up there at the top we have that killer video dot users by city. That's a very common notation. So if we were working in maybe a different Cassandra cluster where we had a whole bunch of different key spaces and we wanted to basically connect to them from a single session in our driver, we could use that explicit defining of the key space in the statement to reference the specific key space without having to do kind of a use this key space sort of kind of creating a context almost. We could avoid that by explicitly defining our key space. It is best practice, even if you are setting up a context to still define a key space, but kind of neither here nor there for us today. We just have to understand that that's what that is. The dot users, so that table name is what we're going to use in our from statement. So select star from that you'd get in a SQL is actually the same thing we're going to use in the CQL. And we're going to use that users by city. So it'd be select star from users by city is how we would reference that. Next, we got our column definitions. Now, you'll notice they're all of the type text. That is just for this example table. The actual list of valid types is, I think it's like 2.5 pages long now at this point. It's in the documentation. We'll get into a couple other types a little bit. We're not going to go deep into any sort of advanced types or anything like that. But just understand there's a lot of types you can use for whatever use case you're trying to accomplish.
And real quick, Eric.
Yeah.
So I'm seeing some questions come in on the various chats asking if key spaces are like a schema. So yeah. So if you're coming from the relational world, you've been working with those types of databases, and you're used to, say, creating a database or a schema, that's very similar to what a key space is in Cassandra.
Yeah, functionally, it's very, very similar. Absolutely. Yeah. Okay, so at the bottom here, we have this thing called the primary key. Now, this is where the Cassandra-ness of this all happens, the good stuff. So a primary key is made up of multiple parts. We have a partition key. If you remember, I talked about partitions are what are distributed around the cluster. So the partition key is what controls that. And then we have our clustering columns. The clustering columns provide 2 things. Number 1, they provide uniqueness to data, which is very important, and we'll get into why. And the second thing is they provide ordering of your data. So basically, you make a partition with the partition key, and then you order the data within that partition via your clustering columns. Okay, so we must have uniqueness to all of our records. Now, that is a very Cassandra concept. That is not something that is necessarily true of every database out there. The reason that is true in Cassandra is the primary key, that primary key that we were constructing in that create table statement there, is actually the address of your data. So, for example, if I had 2 different pieces of data, so say my data columns were different, but they both had the same primary key, and I were to insert one and then insert the other, I would actually end up with a behavior that's called an upsert, where the second one would overwrite the first because the address for where that data lives is the same. That's a very important behavior to understand. It's actually a very good thing that you can use for a lot of really powerful things. But just understand, if you were to take a relational, set of data and just slam it, like a relational data model, and just slam it into Cassandra, you'll end up with a lot of weird behaviors, and you'll actually probably end up losing data from your data set because of that, because of the way the primary key works and some of the differences between the two. All right, we have a couple of good examples and we have a bad example, and I'll tell you kind of why these are good or bad examples. So in our good example, we have a primary key where city is the partition key. So that's how we're chunking everything up. And then we have last name and first name, which are how things are ordered within that partition. And then we have email. Now that's good because it provides uniqueness. Now, if we just had in that bad example there, the city, last name, and first name, we could have potentially two people in the same city with the same last name and first name, right? That's possible. And depending on your name, it could be very frequent. We would only be able to store one of those people from that city in that table in the bad example there. So that's why we provide email as the last part of the clustering, because it provides a full uniqueness that we can use, because no two people have the same email, right? That's a unique identifier. It's a fingerprint that we can use to uniquely identify that person and create uniqueness for rows. Interestingly enough, that second example there where we just have user ID is also a good way to do things in the cases where you are doing single selects, selecting single rows. Now, if I were selecting huge range queries, I would want to construct something much more similar to the first primary key there, where I'm able to return just a single partition per query. Like, that's a good goal to have in mind. But if I'm doing a single select, like for example, a users table or some sort of a login page or something along those lines, having a user ID as the primary key, so a partition key without clustering columns, is totally valid. And because I don't have clustering columns there, I can only have one record per partition, and that's totally okay. So just interesting little kind of caveat there. All right.
So, hey, before we move on, there's actually a set of questions that are really relevant to the material that you're going over right now. One, even though we answered in chat, I'm just going to say this for everybody. Somebody asked, is CQL similar to SQL?
Oh, yes.
As a matter of fact, extremely similar. If you are already familiar with or comfortable with SQL, CQL will feel just like home. CQL is actually a subset of SQL. There are some slight syntactical differences, mainly because we're dealing with a different type of database, but generally speaking, the language and the syntax is the same thing you've been doing. So hopefully, as we go through the various examples today of creating tables, going through some CRUD operations, you're going to see that's pretty much the case.
And just to throw a little bit more color there, probably the biggest difference between CQL and SQL is actually on this slide right here, where it says the primary key and the way we're doing that primary key definition. That's probably the single biggest difference. The only other thing you'd really have to keep your eyes out for would be maybe like where clause. The where clause works a little differently, and we'll get into why that is as well. Right. A little bit. We're not going to go too deep though.
Now, another one that came in here is, should we choose low cardinality column as a partition key?
Ooh, hey, there you go. That depends on use case.
Yeah.
So if I have a data set and I need to be, say, like an IoT sort of example where I've got sensors and I've got them just shoving stuff into a database and I'm going to return a huge range of things, I am going to actually want probably slightly larger partitions than if I were doing a user lookup table or maybe some sort of an address database where I'm pulling single selects. So it depends entirely on use case how you actually want to divide that up. Because if you think about it, cardinality is actually a good way to control your partition size. David, do you think that answers it adequately?
Oh, yeah, definitely. If you've got the differences between high and low cardinality, and if you choose that for a partition, right, that will definitely have an impact on your partition size. So I do agree that it really depends on the case. I think what's more important isn't so much the cardinality, is in Cassandra, you're going to find that when you're choosing your partition key or your primary key in general, you're really looking to answer a very specific access pattern. We're going to get into this later. You want that query to answer one thing, and you're going to go get that one thing. And whatever is in that primary key, you just want that to be unique. So depending on what your data model looks like, and depending on what you're trying to answer, that will dictate the cardinality part of it.
Right.
And one thing to add, we're not going to get into any kind of like indexing or anything like that today. That really comes into play. That comes into the cardinality piece really comes into play a lot with various types of indexes, which we're not even going to there because Cassandra by its nature, and this actually ties into another question that I just saw come in from Abinash over in Discord, says, does it create auto-indexing? Or as are we emphasizing order of primary key? And really, from a Cassandra standpoint, we don't quite... There are indexes, but Cassandra doesn't index quite the way that you would in a relational database. Right?
Not at all, yeah.
So what do you do in a relational database? This is stealing a little bit of what we're going to talk about later, but in a relational database, right, when you create various tables and you create your relationships between those tables, it's very common in the relational sense to say, even if I have a key on an ID, I may create indexes off of all sorts of other fields that are in a particular table, like an email or something like that, right? And I do that for faster retrieval. Well, over time, though, I mean, those indexes and everything, that's still more work you need to do in order to retrieve that data back. Cassandra is all about being able to maintain fast read performance at scale, right? So the goal here is to try to ensure that when we perform that select statement and when we're trying to read something, we can get that back as fast as possible.
You're stealing my thunder, man.
Yes, sorry. So what I'm driving at, really, is that partition key. It's not an index per se, but that partition key, you are literally...
It's a direct lookup address.
Yes, it's a direct lookup to the data. So
yeah.
The focus here, and what we're going to talk about today, is really focusing on that partition key and what you're doing in the primary key, not so much indexing. So to answer the question, does it like auto-index or something? No, not really. That's not how that works here. And you'll see that there's just a different pattern that you use to approach the way that you do things in Cassandra, but it's already, the very nature of it is already optimized for those fast reads at scale.
Right. And we'll get into a lot of that, but it can go really deep on performance tuning through the way you're structuring tables. There's a lot of cool stuff there. All right, so moving on here.
Yeah, let's move on. We've got some other questions, but I think we're going to answer them as we go. So if at any point, we will try to get to all of your questions, but depending on how many come in and how much time, we may not be able to do that. If at some point, though, throughout the material, if you feel like you're not getting an answer to something, ask it, right? And then that way we can follow up.
Right, absolutely. Okay, so we have clustering columns. We talked about partition key. We talked about how that works. Clustering columns provide uniqueness. And this is the same example, the first one here, that we just talked about, how email provides uniqueness, whereas if we just use last name, first name, and city, not so much. The second example there is actually a sorting example. So if I had data and I needed to return it by, say, date, in this particular instance, they're looking at a created at, so some sort of a timestamp, I would need that as part of my primary key because I need to sort data in the way I'm going to retrieve it. So keep those two things in mind. If you get those two things, you're 90% of the way there to data modeling with Cassandra. Okay. So,
real quick, sorry, Eric, I got a really good question. It'll take just a moment. And this is directly related to what you just talked about. CMOS in YouTube says, I don't understand why you need city, last name, first name, and email. Wouldn't it be better to just use city and email? So it is a good question. Yes, it's a very good question. If your goal is to simply provide, a unique user per city, fine. But if you want to order, the key thing is remember that Eric talked about we're ordering on first name and last name. Or actually, I think it's last name and first name, right? So we're ordering on those. So that way, if you want the ability to naturally alphabetically order on, say, last name per a city, that's where you bring those in as clustering columns. So again, it depends. Right. It depends on what you're trying to do. Eric, did you have more there?
Yeah, it literally would change the query from one where you need to know the person's email in the case of where you just had city and email. So your select would have to be, select star from blah, 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 where city equals and email equals. And that would be all you could look up on that table, to one where you could do city equals last name, first name, and then you could return all of the people with that name in that city, because clustering columns are actually optional when submitting a where clause. You have to submit the partition key, because remember, we're talking about how you're addressing the data. There's no indexes here. So you have to provide in your where clause the partition key, but then you only have to provide as many clustering columns as you want, and order does matter. So everything, if you want to get the first name, you have to provide the last name. So that's kind of how some of the finesse of Cassandra data modeling actually plays out. But yeah, that's a really good question. All right, moving on here. So we want to store together what we retrieve together. Again, if I'm doing a large range query, I don't want to have to go all over a distributed system to get all my different pieces of data. Since partitions are distributed as single units, I could just go to a single partition, return all my data back, right? So store together what you want to retrieve together. That's a data modeling concept. Avoid big partitions. If I had an IoT use case, well, actually, I'm going to get into that in a moment. I won't get ahead of myself here. And avoid hot partitions. And let's take a look at examples of all of these. All right, so store together what I want to retrieve together. So here is a perfect example of that of that concept. If I have a list of comments that are on a video, say YouTube. Okay, so if I go to YouTube and I click on a video, under that video I see a list of comments, right? And there's going to be some sort of a video ID that helps me to identify that video. There's going to be a created at date, so like the timestamp, the ordering of the comments on the page. And then a comment ID would provide the uniqueness I need to have all of my comments on that one video within a single partition. So the second example there does not provide me with what I would need to actually create that uniqueness, because I could have two comments around the same time. I could cause upserts. One is safe, one is not, basically. So store together what you want to retrieve together. We're going to avoid big partitions. This one is so key. This is probably, if I had to pick one thing that people get wrong with data modeling, it's they don't put bounding on their partitions and they grow infinitely. And 2 years down the road, maybe you started with a data model that was running really, really fast. But then now we have a partition that's like a gig, which is, in Cassandra terms, that's massive. You see there right at the bottom of the slide, it says up to 100 megabytes in a partition. If you want good performance, you probably want to do like no more than 50. I mean, there's a lot of there's a lot of stuff on that. But basically, you want to bound your partitions in a way where they're not going to grow beyond a certain size. So just keep that in mind, and you do that with some sort of a timestamp or with some sort of a bucketing. I've seen people bucket IoT data off month so that each of their partitions is like a single month's worth of data. I've seen a lot of different ways of doing it. But just make sure you don't just leave something where it's like, hey, this is sensor ID, and that sensor is just going to keep inputting data until the end of eternity. That would not end well for your system. So, okay, we have a good example there where we actually see that created at. That is causing some bounding. The video ID is causing the bucketing, because you're only going to get so many comments on any video, and videos are only going to be commented on for so long before they kind of fade out. And if you have a lot of videos, it's going to spread it out and keep all the partitions relatively even. The bad example there would be country and user ID. That is just going to grow infinitely. Say if it's some sort of a census or something that we're doing, and we're putting all that data into a citizens table or something along those lines, that would just keep growing as people are being born, as people are immigrating in. Like, that would just keep growing and growing and growing, and there'd be no end to it. And that table would be very, very hard to query if, for example, we had two vastly different sized countries. That brings us right into our, oops, I'm getting ahead of myself. That would bring us right into the hot partitions problem. If we say had India, which has a ton of people, and we had Iceland, which has very, very few people comparatively, we would have a partition that is massive compared to the Iceland partition, which would be teeny tiny, and that would also cause a hot partition, because we'd probably be accessing information about India. And if we're accessing individual people, the India partition would be very, very hot, and the Iceland partition would rarely get referenced. All right. Excuse me, I'm talking too fast here. All right, so that exact IoT problem I was talking about is, here's an example of it in the primary key, where we have a sensor ID and we have to report it at, and basically all we're doing is we're saying, okay, give me a list of sensors. They're just going to keep inserting data, and then they're going to put this, they're going to order it by the time that they insert the data, and this partition is just going to grow. It's just going to grow and grow and grow and grow and grow, and it's never going to stop. Interestingly enough, in this particular instance, that would not be a bad thing if I used a TTL on that partition.
What is a TTL?
So time to live. So if I had 1,000 sensors and they were all inserting into this table, then I'd have 1,000 partitions. I could actually count one partition per sensor, right? Because that's how we've structured this table. The TTL is going to go through and it's going to say if I put a TTL of 1 month on this table, it's going to go through and it's going to say, okay, so data in this table is going to live for 1 month and then it's going to die. It's going to disappear. We're going to get rid of it. So essentially, I'm only going to have 1 month of data. I'm bounding that data to 1 month, right? So it's not going to grow indefinitely. It's not going to keep on causing problems for the system. You're going to have a lot of partitions. You're going to have 1,000 partitions, if you had 1,000 sensors, that all have data from 1 month. So pretty cool tool. Understand the mechanics of it, and then you can do some pretty cool things with your data modeling, with TTLs, and some understanding on what actually goes on there. All right. So again, that is a bad way to do it if you aren't using a TTL. Moving on. Okay, avoiding hot partitions. Big partitions and hot partitions oftentimes, not always, but oftentimes go hand in hand. And a hot partition would be one that you're just accessing over and over and over. If you think about it, Cassandra fundamentally keeps multiple copies of data over a distributed architecture. So if you had one piece of data you were accessing over and over, it might have 3 individual nodes within this huge cluster that it makes up Cassandra that are just always hot. They're always getting hit. All the queries are going to those 3 nodes, and none of your other nodes are getting hit. That doesn't scale. So if you were talking about actually making a scalable application, we want to make sure we have a lot of different nodes being hit. We have a lot of partitions that are being frequently accessed, not just 1 or 2. All right, we got some examples of that here. For the sake of time, I'm just going to keep rolling. All right, exercise. Haha, this is where we're getting the good stuff again. So we got this here. Create a table. This is step 2 in that GitHub. Highly recommend you follow along here, or we will give you a couple minutes at the end of this again to do the exercises. So what we're going to do here is we're going to go to that CQL console. Now in your window, if you're at the database screen, it is going to be right here on the upper right, second one over from the right or the left actually. We're going to click CQL console. It's going to ask you for a user. That is going to be the KV user that we made earlier in the database, and that's going to go ahead here. And I might have been sitting idle too long actually. I probably timed out my session. Let me refresh the page real quick.
And we will again, Eric is just going to pop in real quick, and we're going to give you time to go through this and actually read it and do it on your own, and then we'll follow up and kind of give you like a little walkthrough at the end, just so you know if you're like, oh my God, he's just going.
Yeah, I'm not just going to keep going. If you need the username and password, they are, just scroll up a little bit in the GitHub README. They are right there for you. So we got that password. I'm going to go ahead and paste, and there we are. I am now in CQLSH. If you've ever used CQL before, this should look very familiar to you. This is just in a web page. We are accessing CQLSH. If you haven't, but you've used a relational database, there are a million tools out there for SQL using CQL. SQL. That really catches you if you don't watch out for it. There are a million tools out there for other systems like Oracle, MySQL, just the relational databases. This is exactly the same thing as those. We're going to write statements here, submit them, and they're going to work. So the first thing I'm going to do is I'm going to describe key space killer video, and as we can see, there's the key space. There's nothing in it, though. We don't have any tables in it. Nothing has been created yet. So what we're going to do, and you'll notice over here, again, in the README, we are actually going to have the statement to create my table. Now, I'm just going to copy paste because I am in a live demo mode and I want to minimize my risk. But I highly recommend you guys look at what this is. We actually saw this table before. It was in one of the slides. What we're doing is this table is users by city. So basically, we're going in and we're saying we want to get a list of our users from what city they live in. So we want to actually be able to search our database by city. That's what this table is for. It's probably not used for logging in or anything like that. It's just simply going to return address data, essentially. So I'm going to go ahead. I'm going to hit enter there. Whoops, did I? Oh, I'm getting ahead of myself here. We need to do a use killer.
I was going to say you didn't switch over.
Yep, I didn't create my context there.
I'm actually glad that you did that. Because something that Eric pointed out in the very beginning in the slides, that it is a best practice, in fact, to fully qualify your statements. Use things like whatever the name of the killer, the key space, dot the table name or whatever in your query. You'll notice, though, in these examples, I purposely removed all that. And I'm actually forcing you to use. It's really just so you understand that when you're in CQLSH and you want to switch the context to whatever key space that you're in, you use to do that. So you're going to use the use command. That will switch the context into the killer video key space. And then from there, you can execute all the commands. I honestly debated on that one, Eric, if I was going to do that or not. But I decided for this what we were trying to do, I wanted to do it. So I'm sorry it tripped you for a second. You're like, ah!
Oh, it's all good. So yeah, exactly what he was saying right here where it says users by city. If we were doing it where we were being really explicit, we'd do killer video dot users by city. And I wouldn't have gotten an error there, but it also wouldn't have forced me to then use that context. You'll notice in the prompt there, it tells me a killer video right there in the prompt. So that's basically the context I'm in right now. So now if I resubmit that create table statement, that will work. And I can even go back up and you can click up arrow. That's a really useful little command. Oh goodness. Except oh, there we go. Describe key space killer video. Hey, look, there's my table. Pretty cool, huh? And we can see all the definitions there. You'll notice there's all this stuff below the actual table. Don't worry about that right now. Most of that is actually operational and tuning stuff if you wanted to get into it. I think pretty much every single value there has multiple blogs written on it by various people over the years. A lot to dig into there, but you really don't need to worry about it here. And again, if we're using Astra, we're trying to minimize our operations. So not something we should really care about, but it's there if you wanted to look at it and figure out what's actually going on there. Okay, so did our describe tables, got our expected output, and that is going to be the end of the second lab. I'm going to give you guys, what do you think, 3 minutes is enough?
10.
10. Oh,
10.
Goodness. Okay.
Yeah.
All right. We are starting the timer now, and go ahead and run through that. Should be pretty easy. Just copy paste, pick through it a little bit, try to figure out what the different things are. And if you want to, try making multiple tables. Try changing around your primary key. Mess with it a little bit.
And by the way, for those of you who do finish, give us the thumbs up. Let us know. We are trying to give you, even though it's a fairly easy exercise, we do want to give you enough time to actually read and see what's going on in there. So again, if you do get done, just give us a thumbs up and let us know.
I'm gonna pull up my YouTube chat here on the side so I can keep an eye on it and help answer questions.
And from what I'm seeing, a thumbs up so far. Yeah, maybe we go to 5 minutes for this one. We'll wait though.
Right.
Yeah, we'll see.
Okay, at 5 minutes we can ask if anyone still needs time.
Yeah.
Yeah, no worries. No worries at all. Yeah, that's a lot of thumbs up.
Yeah, I see one Daniel Babcock there. Mine is hanging at after use killer video. Curious about that.
Did you? Did it drop a line and put three dots? Because if it did, you might be missing a semicolon.
Yeah, good point. Good point, Eric. That's right. Yeah, if you see a little ellipsis after what you did, it's saying you're not finished with the statement. Put a semicolon there.
Yep.
Oh, yeah. Yeah, I'll give you the Menti code.
Let me know if it's still hanging and we can see if I can get you in hand here.
Yeah, Daniel. Yeah, it's probably the semicolon if you didn't have that there.
Yeah, there you go. Perfect. Yeah, just like SQL, when you're writing out statements, semicolons are important. That's how you terminate. This is the end of a statement. Yeah, we're going to get into some other exercises there as well. I see some people asking about CRUD exercises. The next section, we get into a few different operations here. We manipulate some data and have some fun with it.
So, by the way, Pooja in YouTube has asked, can we just have one key space? So this is actually something new that you can do in Astra. If you go... sorry. I know I'm not showing my screen. I'm just going to explain it out loud real quick and see. Eric, do you have it on yours? If you go to your Astra.
Yeah, I probably can. I don't want to mess anything up.
Well, no, we're not going to do it. I'm just going to show the option. Yeah.
Okay. Yeah, summary. Boom. There it is.
If you go to actions, let's see if you have it on yours.
Right there.
Yep. So that is for Pooja. If you go to actions, you should have a little option under there to add key space. So this is a great question. I'm glad that you asked this. So in the free tier only, that's a key thing to understand. In the free tier only, it was originally limited to just a single key space. However, now you can add more key spaces in the free tier. So even though, if this is especially for those of you, this is the first time and we're doing this stuff with this killer video key space, you're not stuck to that, right? You can actually add another key space or n number of key spaces in there. I don't know if there's actually a limit that I know of.
There are yes and no. There's not a hard this is the number limit, but there are performance implications if you start getting really high numbers.
In the free tier. To be clear, in the free tier, right? Because the free tier...
Well, even in Cassandra as an overall, there are you don't want to just have unlimited key spaces.
Yeah, I'm not talking about a case where you have like 100 key spaces or something. I'm just saying in a case where somebody's just trying to create a couple extra, right? Or something like that. Yeah.
Absolutely. Yeah. Okay, can we get in chat here? Does anyone still need time, or we're looking pretty good? Keep an eye. Okay, I'm not seeing anyone saying that they're massively short on time. How do I view the table I just created? Yeah, that's basically that describe table command. I'm sorry, did I show that one? I might have not shown that one. Or you can do describe keyspace killer video, and those commands are actually right over here. If I'm already in the killer video context, I can just do describe tables,
right,
and that will bring it up.
That's right. And as a matter of fact, in the README itself, right under the command to execute the create table, there is a describe command for that.
Yeah, that's what I'm showing right now.
It is okay. Okay.
Yeah. All right. I think we're looking like we're all good here. So I am going to end it here. We're going to end at 3 minutes. So a little bit early. That is fine. That is excellent. All right. So moving on. The art of data modeling. We actually created something in our database. Now we actually get to learn a little bit more about how to do it right. All right, so we're going to start from a relational data modeling standpoint, and then we're going to kind of do a mind shift here. So follow along with me. Feel free to ask questions. David, stop me if you're seeing questions or if something doesn't look like it was clear. Let's get through this. All right, so in relational data modeling, you start with your data, right? And part of the concept there is you're trying to maintain, very, very good data integrity. You don't want to have a lot of copies of your data. There are a lot of things that you're trying to kind of mitigate. But you start with your data, you build out your data models accordingly, and then your application will consume that data. Generally, there's kind of a step in the middle there between your data model and your application where you're making indexes. You're doing all this stuff. We've always talked about third normal form. I remember, I think my first database class in college, or one of my early database classes, the teacher goes, third normal form is your world. It's what everything uses.
That's been the world that many of us in the relational world have been in for decades, right? We're used to doing it in that way.
Right, and it makes sense. I mean, if you think about the way that system functions and the concerns around the time that the systems were created, it actually makes a ton of sense why third normal form would be a thing. But you see a little pro-con there, right? Simple write, high data integrity. The cons are slow reads in complex queries. I think we've all had nightmares. If anyone here has used databases, we've all had nightmares about like a 2-page long query in SQL and just the trying to debug that and trying to make it work and trying to make it performant. I don't even know if you could make something like that performant, like actually perform. And the reason for that is, with the relational database, we do all the processing on retrieval of the data, meaning when we want something back in a certain format, we have to structure it. We have to actually kind of almost, in some cases, run kind of analytics kind of feeling jobs to get data back in the format we want it. Now, in denormalization, which is how you use Cassandra, we do exactly the opposite. We do all of our processing of the data on the front end when we're inserting it. That way it lives in the database in the way we want to access it. What this means is we can do really, 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 really fast select operations, because all we're doing is saying, here's the address of what I want, go get it, and it says, okay, here it is. Boom. That's as complex as Cassandra queries really get when it comes down to it. Okay, so really, really, really fast, and that's due to denormalization.
Yeah, and for those of you who are used to, again, coming from the relational world, you're used to doing it a certain way with normal forms. But if anyone's worked in data warehousing, right?
Right.
Then one of the ways that we would speed that up from a data warehousing standpoint is what? We'd flatten out the tables. We would denormalize.
Denormalize.
So it's the same. Yeah, that's right. Oh, no, did I say it? Yeah. So it's the same pattern. Yes. That I think Eric is probably going to talk about. I think I just stole your next slide, Sundar. I'm so sorry, Eric. I totally preempted the next thing. But yeah, so if you are familiar with data warehousing, you may have done something like what you do in Cassandra before.
Yes, absolutely. That is an excellent point. Everyone, third normal form is largely understood to not be performant on the reads. And so analytics jobs or things like that, almost always you go in and you actually denormalize first. But yeah, excellent point. Okay, so NoSQL data modeling. You remember that one where we started with the data, we moved to the models, and then we moved to our application? We actually flip that on its head. Because if we're trying to store the data in the way we want to retrieve it, we have to know how we want to retrieve it. To do that, we have to actually start with our application. So we actually have to sit down, we have to ask ourselves, what queries am I going to run against this data? From there, I can go out and I can build my data model. So I can actually structure tables that directly answer each of my queries. And then, of course, data comes right after that, and it's actually the last step instead of the first. Really, really mind shifty, but if you can absorb that, it's huge help throughout this process. That's probably going to bring up the question, wait, what if I have the same piece of data and it's over multiple tables and I need to do an update? What do I do? there's a thing in Cassandra called batch. Now, this is not a relational batch. It has nothing to do with relational batch. Please don't use it like a relational batch. It'll actually horribly fail at trying to do what a relational batch does, because it's not what it is. What it does is it helps you to keep your data in sync between multiple tables. So same data across multiple tables. If I had 2 users tables, maybe users by city and maybe users by email address, those would be 2 different tables. But a lot of the information is going to be the same across both of them. So I would use a batch when I'm inserting information. Say if I wanted to update like a street number, for example, I would put that in a batch update statement and update multiple things that way. Just know it's there. Understand it's not for, like, SQL batching. That's not what it does. All right, yeah, moving on. All right, so the design process is actually pretty simple to follow. We got to build out our conceptual data model. We use our application workflows to help construct that. We map those 2 together. We get our logical data model. That's quite hard to say. Logical data model. We do our physical optimization, and then, of course, our physical data model. So let's run through that a little bit. So conceptual data model, we want an app. We know we're going to have users that log in. We know we're going to have comments on videos, and we're going to have videos in there. What do we need there? We know we're going to need, at least for the users table, some sort of a user ID, probably some sort of an email address that they can use to log in, something along those lines. For the comments, we're going to need some sort of a timestamp, some sort of a text of what the comment is. And for our video, we're going to need some ID to identify the video, probably a title, some sort of description. Those are kind of some general things we can know right off the bat. We're going to need these for our app to run. Then we can go and we can actually start thinking about what our queries are. So as a user, I open up a video page. What do I want to see? Well, I want to see the video, but I also want, let's focus on comments for a minute. Just like YouTube, I want to see a list of all the comments on that video. I want to be able to read through them, see the interactions, maybe participate in those interactions. That's kind of important. So I am going to go through, and I'm going to need to make a query that does that. Second use case here, if I open my profile, I want to see all the comments that I have made as a user. So those are going to have to be 2 different tables. They're both about comments. They're both comments tables, but they both are answering a different question. So we're going to need 2 tables to do it.
So there's something really key, right? I just want to interject here. There's something really key to understand about what Eric just said, right? So we're going to have 2 different tables that have like information, and we're going to store that like information in those 2 different tables. If you were to do this from the relational standpoint, from a third normal form standpoint, what would you do? Right?
You do a join.
You'd probably have a table with the comments that had some comment ID, and then you'd have like your video based ones, and you'd join over to that comment ID, or whatever users had those comments, you would join over to that comment ID. Right. In this case, though, from the denormalization data pattern, we are actually going to store multiple copies of that data, and in Cassandra, that's totally okay. Right? Again, the point is to optimize for the read performance at scale. Right, that's really the key thing, and so for some of you who are coming from the relational world, and you've been doing it in the normal form way for a long time, that might feel really ugly, right? You're like, oh God, wait, you want me to copy the data? Like I have to, it has to exist in multiple places, and we're saying yes, in Cassandra, that's totally okay, right? And it's a balancing act with the types of resources. Like if you think about when relational databases were made. And for those of you who might be old enough, right, when disk platters were like this big and they store like 5 megabytes or something like that, they weren't very fast. You had arms and spindles that had to move around on the disk to actually get the data compared to things like SSDs today. It was a totally different world. So the databases had to be optimized to have, essentially
little redundancy as possible.
Right, a small amount of data and to be able to get to that data fast. And it's changed. The game has changed. And so now Cassandra essentially is taking advantage of the fact that we have much larger, much faster, much cheaper disk than we did back, and it's able to leverage that to get really nice performance gains is what it comes down to.
Right. So we got a question here. Is batch like a transaction?
No!
Can it be rolled back? It is not. No,
yes.
Not at all. All you get from a batch is a very strong retry and a notification if something fails. So Simple answer is no. Definitely something. Go do some reading on it. We're just we're providing you enough that you can know what to Google, but we're not diving into the full how it works. So definitely go read up on it. There's a lot of stuff on logged and unlogged batches if you want a couple terms to do some research on. Highly recommend checking them out and kind of understanding what's going on there.
And
but
at the end as well, we will point you to some resources that if you want to follow up and you want to learn more about this kind of stuff, those resources you'll be able to go and explore right away. So we will talk about some of that at the end.
Yeah, no, absolutely. That's right on. So, all right. So moving on with the presentation here. So we talked about we need these two comments tables, right? So our queries, one of them we need a comments by user. The other ones we need comments by video, right? If I'm on my profile and I'm looking at what comments I made, that's comments by user. If I'm on a video and I'm looking at what comments are on that video, comments by video. That's actually a really popular naming convention and kind of the accepted standard, honestly, at this point, for how you actually name your tables. So what are you trying to retrieve? Comments. And then what are you trying to retrieve it by? So by user. Pretty simple. Hopefully everyone gets that. All right, so those statements, the actual query itself, this looks like SQL, right? This select star from table name, where, and then a where clause there. Pretty simple. And that's goes back to CQL is a SQL-like language. So keep that in mind. The important thing to know here, if you just go in and start writing random where clauses on, say, like data columns, you're not going to get data back. In fact, it's going to freak out at you. Reason for that is that if we're addressing the data by that primary key, remember that partition key and clustering columns, we have to provide the address for what we want to retrieve because there is no indexing here. There's no magical way it can just go out and find that piece of data within the larger data set. It needs the address for the data. So think of it like primary key equals the address or the identifier I will provide to get my data, and the data columns are the payload I want to receive back. Pretty simple. Okay, so logical data model. We're going to need a whole bunch of things here. So comments by user, we have our user ID. That's going to be our primary key. The K means, the partition key. K means partition key. C is clustering column here in this particular instance. And then we also have the arrows indicating the ordering direction. We have our creation date. We have a comment ID, video ID, and of course a comment. In the comments by video table, we have a video ID. We have a creation date. We have a comment ID, user ID. Notice that used to be in the other table. That's what the partition key was, but in this one it's video ID. And then, of course, the last thing is comment. Okay. Yeah, I should point out there.
Yeah, go ahead, Eric.
Comments is actually the payload. So if we think about what's the data column here, it's comment. That's what we're trying to get back.
By the way, something to point out, these diagrams that Eric are showing you, or Eric is showing you, they're called Chibako diagrams. It's just a notation that's used when doing data modeling in Cassandra that
makes it easy to understand.
Yes, makes it easy to understand. Where's my partition key? Where are my clustering columns? What's the order? That kind of thing.
Yeah, absolutely. So I see a question here. What is the use of an ordering? What is the use of ordering comment ID as it is going to be a UUID?
So I'm so glad you asked that question. Actually,
we'll get there.
Yeah, we're going to totally adjust that. Yeah, go ahead.
Yeah, if I miss it, pull me back to it. How about that?
Yeah, because you're right there at that spot. So, right. Matter of fact, if you want, what we could do, let's just belabor this for a moment. If you could go back one slide. By the way, Turan in YouTube, that was a great question, and we were just about to go to that. If you go back to the logical data model slide. Oh, you are on it. I'm sorry, the feed was lagging and I didn't see it.
Oh, I'm sorry.
Yeah, back to the logical data model. There you go. Okay. Okay, so if you take a look, right, and that was very observant to notice. Notice here, the logical data model, as we're determining what kind of fields I may need to support my comments by user and comments by video tables. You'll see here that there's a creation date and a comment ID. Now, those combined with the user ID are going to give me that unique row, right? But I have this creation date and a comment ID. Now, could I leave it like this? Yes. And to kind of answer what you were saying there, if you order the comment ID, wouldn't that just be a UUID? Well, in the case of the logical data model, if I left it like this, Yes. If I had a separate creation date and a common ID, you're absolutely correct. That would just be a UUID. Would there be much use in ordering that? Not really. Now, Eric, if you go to the next slide,
Yep.
for the physical data model, watch what happens here. The only difference between these really is you take the logical data model step. The physical data model is just an optimization. Is there anything I can optimize as I go to now implement these tables? And if you notice, common ID is now just one field, but that one field is a time UUID. So what we did is we encapsulated down the creation date and the common ID into a single field, a time UUID. The time UUID stores a UUID and a timestamp in that single field. So in this particular case, now when we order by time UUID, it will actually be naturally ordered. And what's really cool, if you think about it from the case of like an IoT standpoint or like this, where we have comments that it's probably relevant to order them by date. Because if I'm looking at, a video and I want to see all the comments, I don't want to just see the comments coming in random order. I want to see the latest comments or the most recent ones there at the top of my list.
Right.
So as Eric explained earlier, when you write stuff to Cassandra, you're optimizing for things like order and such up front as you do the write. So what happens later on when we perform the read here, because that common ID is a time UUID and we're already ordering in a descending fashion, when I read that data out, it's already ordered. I don't have to pay the cost for that on my read, right? So it's a little bit of an optimization. Now, could you implement this the way that we showed you in the logical data model? Yes, you totally could, right? Just encapsulating these down into that same common ID field is just an optimization. So
It's
to
an
answer,
efficiency thing.
yeah. So to answer the question, what is the use of ordering common ID as it's going to be a UUID? If we had not made that optimization, totally with you. But since we optimize it into a time UUID, now we can order it and it will order by time. Thank you for that little side conversation on that, Eric.
All right, so moving on then. So the actual create table statements for these tables are right here. Remember these? Actually, you don't need to remember them. We're going to give them to you again. But you'll notice there I talked about we're going to use some different types later on. We have user ID of UUID, comment ID, time UUID. We still have our text field there on the comment. There are a lot of types. I highly, highly recommend everyone go and just look at the page there. There's a lot of good stuff. Are we able to drop that in chat?
What's that?
Have that handy?
Which one?
Types documentation page.
Yeah, as a matter of fact, it's in the README itself.
Yeah, right. Excellent.
It is in there, but let me. I do drop it in there later on, but I can pull it up and drop it. Yeah, here.
Perfect. Yeah.
Yeah, I do talk about it.
Yeah, perfect. All right, so that's going to actually bring us right into our next exercise. And let me get back to the GitHub. All right, perfect. So this is going to be. Oops, there we are. So step 3, there's the table of contents there. You can click on that, or you can just scroll down till you see it. Number 3, execute CRUD operations. So CRUD operations, excuse me 1 second here. Getting a frog in my throat, goodness. Okay, CRUD operations. Someone asked earlier if we're going to get to play with CRUD operations. Yes, we are. Let's create 2 tables in our killer video key space, and let's actually start manipulating some data. So I'm going to copy both of these. I'm going to come back over to my CQL console. I think I actually need to log back in because I did navigate away, so give me 1 moment to do that. And that will happen here. Goodness, it's taking a moment. There we go. KB. All right. So now I'm going to have to use the key space again. If we remember, use killer video. There we go. And I'm going to go ahead and I'm going to create those 2 tables. All right. Now, just for the sake of illustration here, I'm going to go ahead and describe. Oh, that's right. Killer video. And we will see those tables are created. So I have my users by city from before, but then I also have these 2 comments by video and comments by user. Okay, and those look exactly the same as we've talked about throughout this entire thing. Now, I will say, if someone asked about ascending and descending, you'll notice right there we have this with clustering order by part of that table. Default is the descending there. I didn't go and specify like ascending, descending on that. But if I wanted to, I could have typed out with clustering order by comment ID ascending if that's how I wanted to order it. Just kind of a note there. Okay, so let's go back and let's actually take a look at the data we're going to be playing with. Now, we have this insert statement here. This one's all kind of broken out, and then all the ones after it are all just kind of one-liners, or I think two-liners, actually, but yeah, you get the idea. These insert statements should look exactly like what you'd expect from pretty much any other database you've used. Insert into, having the table name, having which particular columns you're going to insert, and then a list of values. Exactly what you'd expect here from anything else. There's no secret sauce or anything you're having to keep an eye out for. I'm just going to go ahead and I didn't select the whole thing. I am going to go ahead and select those, and I am just going to paste them in here. Now, as those run, which is really, really fast, you'll notice that these UUIDs are kind of contrived. There's not the chances that we get a UUID of 1111111, etc., and 2222222, etc., are incredibly low. We are inserting these in this format for the point of illustration. I would actually probably use a UUID function that is in CQL, and actually you'll notice the now function is the time UUID equivalent of that if I were actually inserting real data into videos. But since we're going to be manipulating stuff and kind of using examples, that's why they are the way they are. Just wanted to point that out so no one wait a second, that's not a real UUID. Yeah. All right, so let's select star from comments by user. And we'll notice we have data in our table now. Pretty cool. It has user ID, comment, and video ID. So lots of UUIDs, and then there's just block of text. Wonderful. All right, we're also going to go down, and we are going to insert some data into our other table here. Let's do that here quick. Oops, wrong way. I am totally switching across things. All right, there we go. So insert some data there, and let's write a select star from comments by video. Video. And we have data in there. Now, important to note, I just did a select star and I left it unbounded, and that's bad in any database. If I were to go into, any of the traditional databases where there's maybe a few terabytes of data being stored, and run a select star and hit enter and leave it completely unbounded with no safety whatsoever, what happens? What's the first thing that happens? Well, my phone tends to ring, and there's an angry DBA on the other end asking why I'm doing bad things to their database. Same sort of thing will happen in Cassandra. Don't leave your queries unbounded. It's actually even worse in Cassandra because now we have this network layer in the middle that really just kind of adds a whole lot of extra fun into that situation. Don't do that. We're doing it here for the sake of example because we have really small tables. They're controlled data sets. 4 items in each table. Nothing too big to worry about there. But just understand, don't go into Cassandra and just, boom, select star from, enter. Bad things can happen to you. All right. So I just got some data back. I did the select star from unbounded. If we wanted to bound that, we would use the where clause. So quite simply, we had a UUID, and remember, we have comments by user, so we're using the user's user ID. This table could actually be called comments by user ID. That would be a valid name as well. So I provided it the user ID of 11111, etc. And notice I got back all of these 3 rows. Now, if you remember, we had 4 rows in that table, but here, if I can scroll up, one of them was all 2s. So that one didn't come back. Works exactly like you'd think a filter would on any SQL database. It filters off of values and won't give you what you didn't want, basically. All right. So we already executed those commands, so we're going to skip along. Sorry if I'm doing this a little out of order. There's just a lot to cover here, and I get all excited. All right. here's the cool part. So what if we wanted to update some data? Well, we could write an update statement, right? Yeah, we could write an update statement, or I could write an insert statement. Think about that for a second. We talked about this a bit earlier, but if I have two pieces of data that are both using the same primary key, basically the same address for where that data lives, and I do an insert, the insert the one and then I insert the other, the second one will overwrite. Interesting. So if I were to go ahead, actually let me do a select before I do an update. So if I do, which table were we manipulating there? Comments by video. So I'm going to do a select star from comments by video. Actually, we have it there already. And then I were to go ahead and do an insert statement, right? And I do select star from comments by, where is it here? Video. Boom. Notice, how many do I have in there? How many records? I have 4 records.
I don't know. You're showing a different screen, I think.
Am I? Is it not showing?
I don't see your Astra screen.
Okay, that's not good. Well, I'm on it. I'm running all sorts of commands.
I know. I'm looking at the thing, and you're on the README for the GitHub repo.
Oh goodness! Should I try to reshare my screen?
I'm not sure. Move your mouse.
Okay, I'm moving it.
Oh, yeah, it looks like for some reason that I don't know if it's stuck or something, but I don't see your screen changing at all.
I can, yeah. Let me reshare my screen. So
okay.
let me stop the screen share here.
I was wondering as you were going. I was like watching the screen. I was like,
yeah. Is it gonna let me? Oh, it doesn't even think it's screen sharing at the moment. That's not good. Screen share. Come on. Yeah, I might. Would it kill things if I killed Skype?
Oh, now this is very meta. If you kill Skype, well, I guess if you have to, this is very meta. Yeah, I'm watching myself. This is very strange.
It's not letting me stop my screen share. So, it caught up. Like, can you see it now?
I see me pause in a very funny face in Skype. Okay, I do see your Astra now.
Okay, good. We'll hope it keeps up, and we'll roll with that. All right. So, excuse me. All right, there we go. So, kind of illustrating what I was just illustrating. Where is it here? Oh goodness, I got thrown off track then.
Yeah, sorry about that.
No, it's all good. Did that? Okay. And that's the one. Perfect. All right, so I'll just rerun that same statement. I am going to go ahead, though, and you know what? I might have just found a typo in our README.
There are no typos. There are no typos.
I'm sorry. There are no typos. Yeah. I'm going to go ahead and I'm going to open up a note, I think. Or actually, I'll just do it here. New file. Boom. Let's do a completely new file so I can edit one thing. And the reason is, oh, come on. New file. Boom. Test. CQL. All right. I'm going to paste that statement in here, and I'm going to change the word geek to
on fleek.
Yes, and then I'm going to recopy that statement. Oops, I don't want to go over there. I'm just going to switch back. Do you see my Astra instance again? I don't know if it...
Yeah, I do see it. I see you switching over to
okay.
Looks like VS Code or something.
Excellent. So now I'm going to go in and I'm going to submit that statement. Now we can see right above that it says geek there on the very last line. But if I submit that and then I do a select star from comments by video. Oh, look at that. 4 records, but one of them changed. I just used an insert statement to perform an update. Mind blown, right? This is kind of key, and this actually illustrates a really good point with Cassandra. Almost everything you do, updates, inserts, and deletes, are technically speaking inserts. Deletes are basically just inserting a marker that this data is now deleted. Updates are basically inserting change data. Inserts are inserts. Really, really crazy concept, but once you wrap your mind around it, there's actually a lot of really cool stuff you can do with retries and things, where you don't have to worry about a lot of the things you have to, like, oh, am I going to get a duplicate record? Is something going to happen there? Like, no, this is Cassandra. It's just going to perform the upsert behavior. So, kind of interesting point.
Mm-hmm. And this is all about performance. This is how the fact that when you update or you insert data into Cassandra and the way it writes, we're not getting into a lot of the details of like the write path or anything, but the way it writes data has everything to do with the fact that Cassandra can perform at scale. When we say perform, let's put this into context, right? Writes in Cassandra are usually in the order of microseconds or very, very tight milliseconds, right? And achieves this because it does not perform a read before a write. It actually appends on to the end of a file and just moves on, right? So and if you imagine, if you were to try, especially if you have a Cassandra database, as you start to scale up, as you start to get a database that has, say, imagine a database that has 1,000 nodes in it or something like that. And imagine then for every time you try to do an update, you would do a read before a write or something. That'd get really slow is what it comes down to. So Cassandra is optimized for performance, is optimized for speed. And this is one of the ways that Cassandra does that.
Precisely. So just to illustrate that we're doing essentially the same thing with an update command, I've got another update command where I am going to type out that, let's see, we're calling Patrick a creep now. Okay.
No, on fleek. He's on fleek. Where'd you see creep?
Right now, but I might have edited it myself.
Oh. I was like, that's not in there. That's funny.
I'm sorry. I mean, David wrote it, Patrick. If you're listening, David wrote the command.
Nice,
I totally didn't just do it on screen. Okay. So as you'll notice there in the actual data, we performed an update statement, set where, just as you'd expect, and we basically set comment ID to a slightly different value. And we can see it there illustrated. Okay. All right. Last step. We're going to actually perform a delete. Now, like I said, remember that Cassandra, when it deletes, it actually just stores a marker that, hey, this data is now deleted. There's a whole bunch of reasons for that. If you're curious, there's a whole lot of blogs. There's a lot of good content on that as well. That could be a whole 4-hour session in and of itself. So we're not going to dive in and really dissect it. But there's a lot of really cool stuff and a lot of really cool mechanics that happen there. Okay, so delete command, we're actually going to run that. And we're going to go ahead and we're going to reselect. Select star from comments by video, and now Patrick is no longer in there. We have 3 records. We actually deleted it. Now, I told you it inserts a marker that this data is now deleted. It's not a marker we would see returned from the driver. There is some expanded features we can turn on to actually see what's there and to show what it's called a tombstone. We can show what tombstones are there. There's stuff we can do there. But from the driver's perspective or CQL's perspective, it's just not going to include it in the select because it's now marked as a deleted value.
Yeah.
Okay.
So we do have a question. I knew this was going to happen, and it's one of my favorite topics, actually. We do have a question of tombstones, right? Mm-hmm. So if you remember what we were just talking about a moment ago, where Cassandra is optimized to be extremely fast on writes, and when you're performing options or operations, things like an update or whatever, it doesn't perform that read before write. And that's the same thing for a delete. Matter of fact, a delete is in fact an insert. You're actually inserting what's called a tombstone. A tombstone is just the delete marker. All it does is says, this thing that I just deleted is now marked for deletion. Now you might ask why? Why would you do that? Well, Cassandra is a distributed system, right? So part of that is when you have a distributed system and you have the same data that might be on multiple nodes in that system, you need some way to ensure that they're all in sync when you do something like a delete. Because what you don't want to have happen is you don't want to delete the data, and for some reason, if one node was down or something like that, you don't want to have it come back up and then throw that data back into the system. That's called zombie data. right? Not only that, again, Cassandra is optimized for extremely fast writes. So if when you deleted, you had to wait for the delete option, go read, go remove all those, and wait for it to come back, it would not be very fast. So delete essentially, or so when you say delete, you're actually going to set those tombstone markers in every place where that data may exist, and that's being done asynchronously per node, right?
Right.
And it's done, and it just inserts a delete statement, and it's super fast. That's kind of the idea. I'm glossing over a lot there.
There's a whole lot there, that
Yeah.
we could dig into. And if you guys have questions, I think we are going to have time for an AMA at the end of this. It won't be a long one, but maybe 10, 15 minutes. Feel free to ask them there. There's a lot of aspects of a distributed system, a masterless distributed system, because there's no master here.
Yeah.
It's all pure architecture. If you guys have questions, feel free to ask them. We are more than willing to answer.
Okay, so
all
we're
right.
going to get everyone some time to go through this on their own.
Yes, exactly. So I am going to start a timer. This one's a little bit longer.
10 minutes, I think 10.
Okay, yeah, we can do 10 minutes again. That's fine.
We'll find out if...
Let's see, I think I need to refresh the page to get it to reset the timer.
Oh, really? Oh, okay.
Yeah, it's always been a little weird for me. But all right, so 10 minutes running now.
And this is to go through this is step 3 with all the CRUD
step
operations.
3. Yep, CRUD operations. Let's see, kind of look for questions in the YouTube chat here. Is there a way we can roll back a series of inserts? No. So there is no rollback. This isn't a transactional database. This is and that's actually a good thing. Trying to think of how to explain this without going into kind of another long thing. But when you look at all the ways that everything's working here, that's actually a good thing. If you aren't sure you want to be inserting data, don't insert data. If you the transactional nature of relational databases is actually there to combat some problems that we don't really have in Cassandra. So that's the simplest, shortest way I can say it without kind of taking a longer time. David, if you got any color there to add, feel free. But let's see. Oh, here's an interesting one. I really wonder why there are a lot of different tools that look similar, why we have MongoDB, Cassandra, Hive, etc. That's actually a very, very interesting question. Kind of why does CQL look like SQL, and why do all these things look so much alike? Oftentimes it's for adoption purposes. So if a developer is very familiar with one system and is able to kind of just step into another system without having to learn a whole new syntax and a whole lot of new pieces, it helps with adoption. And if you think about it, Cassandra's only I think 11 years old now?
Yeah.
11 years old. So coming into a world where MySQL and Oracle were basically, that's what you have, trying to make an easy way for developers to cross the line is a really, really big deal. So, yeah. What is the underlying clustering system? K8s or Docker? Cassandra is it has its own clustering mechanisms. There's a whole lot of operation stuff there. We can dig into that a little bit in an AMA if you guys want to re-ask that question. But no, it's not Docker. It's not Kubernetes. It is actually handling all of that on its own through some stuff called Gossip. And there's a lot there. We can
now, funny enough, you can deploy Cassandra with Kubernetes and Docker. There's, in fact, a Kubernetes operator that we released this year that it's open, that you could use for open source Cassandra. So you can do it that way, but yeah, underneath the hood, Cassandra is not using Kubernetes or Docker on its own.
Right. Yeah, the clustering is done through Cassandra entirely. Let's see here. Is there a metadata table to get R counts for all? Ooh, good question. No, there is not. That is actually a really interesting. That's an interesting question. I don't know if I've had that question before. But simple answer is no, there's not. There's not a simple place to just retrieve a number of rows.
I'm trying to think though. In Cassandra 4, some of the new virtual tables that are coming. I don't remember if they.
I don't think they have row counts.
I don't think so either. I'm looking it up to see if I can find it.
Yeah, you got us
unless one of our folks online. I'm going to ask the team as well.
Yeah, it's a good question. Yeah, so for context there, Cassandra 4.0, which is in, I believe, open beta, it has a new feature called virtual tables, which are a whole bunch.
Cool.
They're very cool. It's settings and stats that you just would not have had in any of the older Cassandra stuff. So there's a lot there to dig into. Yeah, I'm not sure if row counts are in there.
Yeah, I'm looking.
Any catalog tables? Not sure exactly what you're referencing there, but no, I don't believe so. If you're talking about kind of a schema catalog or something like that, not really.
You know what I will do is let me drop the. I will drop a blog post from the last pickle. By the way, if you are new to Cassandra and you're not familiar with the folks from the last pickle, take a look at their blogs. They have wonderful posts that get into a lot of details. So if you really want to get into the nitty-gritty details, they're great. So I'm going to drop this link. This will explain the virtual tables coming with Cassandra 4.0. For some of you that have some of the questions about catalog tables or row counts or something, you'll be able to see what's available.
In full disclosure, the last pickle was actually so awesome that we went out and we recently acquired them, and
they're now part of DataStax, but they're still operating like the last pickle. We leave them alone mostly.
They are an amazing group of people. So yeah, absolutely. What is the difference between Cassandra and Big Table Google? Oh man. So very much.
Well, and one thing just to kind of keep in mind that, Cassandra was actually, when it was built based on both Big Table and the Dynamo paper. So there are some similarities in where it comes from, right? But I would say...
But a lot of the mechanics of what's actually going on is fairly divergent. Again, that's one that, if we had an hour, we could talk the operations and what really functionally is different. Can you please elaborate a little bit on UDT versus table in Cassandra? So user-defined types, I'll go into them a little bit here. I don't want to get too deep in that. User-defined types are a thing. They have their own individual performance impacts. There's actually three kinds. There's map, list, and set, I believe. Each of them has their own performance implications. None of them should be used to make kind of nested databases within databases. It's actually a really, really bad thing to do in Cassandra, because essentially you're artificially able to, you're basically causing, beyond retrieval problems, you can actually cause large partition problems. There's a lot of just kind of muck and mire you can get into by misusing them, but they do exist, and there are right ways to use them, and they are actually a very powerful tool. Just understand what you're trying to do and do it, correctly. Thanks for the info. What version are we using? Version of Cassandra that Astra runs on? You know what? I don't actually know what the current version is. They are pretty good about keeping it fairly up to date.
I want to say that, I believe that it's actually got part of 4 in there, in Astra.
Yeah, that sounds right. They're really good about going through and vetting things, and actually they provide a lot of feedback to the greater Cassandra community on issues they find and various things. So they keep it fairly up to date. Yeah. Let's see.
All right, so how are folks doing on their exercise? Can we get thumbs up?
Get some thumbs up there.
Yeah, for the folks that are done. See where we are.
Yeah, I got another question too while we do that. Does Cassandra have a DBA underscore tables or views or SP functions like SQL Server? David, that's probably one you could answer better than I could.
I want to say that a lot of that's going to be covered in the virtual tables.
Yeah.
Again.
Got a singular thumb up so far, so I think. Yeah, let's give it. Oh, here a few more coming in. Yeah.
There we go.
Okay. Yeah.
Oh yeah, from views. That's right.
Oh,
materialized
okay.
views. Yeah, I missed it. I missed the same question.
Yeah.
I read that
I did
differently.
the same exact thing you did.
Yes. So from a view standpoint, there are in fact materialized views, but as mentioned right there, that they are considered experimental. So there are something that you really have to hit the right sweet spot of how to use them properly.
And even then, some of the controls around them are, as an experimental feature, are not really production ready. There's some things with keeping them in sync and things that are just a little shakier than a lot of the other features within Cassandra. Part of the reason they're marked as experimental at this point. But if it's something that you have a vested interest in, feedback in the community is always a good thing. Let's see here. All right, about 30 seconds left, and then we will go straight into, I think, an AMA. Well,
we've got the last. Yeah, we got the Menti. Yes. Yeah, we got to do the quiz.
We got the Menti, last of the presentation, and hopefully we have a couple minutes to kind of take more questions, but we will see how that goes. All right, so 20 seconds. Sorry for drinking on camera here. I'm just got a dry throat, so have to keep sipping stuff. Goodness, that is so loud. All right. So, going back to the presentation, Menti. So if you need the QR code, we're going to keep it up there for a minute. Go ahead and scan that on your phone, or just go back to your Menti app if you were already part of the quiz last round.
You mind put? Oh, there it is. Good. Okay, it was just lagging.
So,
cool. I'll just give that a moment.
There's about a second lag between the YouTube channel and what we're saying. So if you're watching it from the YouTube channel's perspective.
Yeah, so we'll give you a moment to either scan the code or go back to Menti. I will drop this in here as well.
All right, and if you want to switch over, you should have enough time here.
Okay, and I see folks bringing thumbs up in already, and I will pop that open. All right, we should see the Menti. Now I've had Menti sit. Here it goes. It was slow on my end.
There we go.
Yep. Hold on. Sorry, my bad. Hold on. Menti is lagging. So there we go. All right, I'm gonna give a moment. I'll give a moment. Let everybody get their names in. This is always the funny part. All right, and we will do this. Now, key thing, look at your phones or where you're running Menti. What is a primary key? Yeah, look at your phone. Same as a partition key, uniquely identifies a row. It's a column in the partition key. It's the main house key. And there we go. Yes, it uniquely identifies a row. Yeah, it is not the main house key. That was a joke. You may have noticed that we put little jokes in here sometimes. It's usually like the last one. But, all right. Let's move on. Let's go to the leaderboard. We're going to see now. This is the fun part of this, right? All right, so it looks like you have these top three, but then the timings get put into place, and let's see if anything changes. All right, well, the first one, it doesn't. So we've got Ronald on top, Homer right behind, and then Dragonite in third place. And, you know, funny enough, some of these I recognize. I wonder, though, if that's Menti's doing it, if they didn't put names in. All right, next question. And again, look at your phones. What is the partition key? A consecutive number applied to each new record. A designated field in your table structure to partition your data. An optional table field for optional partitioning. Another word for garage key.
Got a lot of keys here.
A lot of keys. That's right, good. Most of you saw it. A designated field in your table structure to partition your data. Exactly. I'm actually, between those two questions, the fact that the vast majority got those right, I'm happy. I feel like that worked out.
Yeah, that's good. We've done some good work today.
All right, let's see where we end up in our leaderboard. again, the top 3 will get swag from us. So Daniel, Akshay, and RS.
Ooh,
oh, I see Pooja.
Yeah.
I wonder if that's the same Pooja we've been talking with in YouTube. So, not that I'm calling favorites or anything like that. So. All right, next one. What is Astra? Dun, dun, dun. It's a local in-memory version of Cassandra. It's a Cassandra as service in the cloud, a development tool, or it's a gateway to the stars. Yes, it is the service you are using right now. It is Cassandra as a service in the cloud. Essentially, they're like an easy way to spin up a fully managed Cassandra database if you don't have the want or need to do that on your own. So it's service in the cloud. By the way, most of you probably use the AWS version of that. You can do it in GCP, and Azure's coming. I saw that question earlier today. All right, so RS takes the lead. So this is always anybody's game with these, right? And we have Akshay in second place, and then Shashi has taken up third. All right, let's see. We've got just a couple more here. What flow is used to create data models in Cassandra? Data, models to application, models to application, then data, application, models, and then data, or create data models.
It's got to be number 4.
Yeah, right. That's right. The key thing about this is you start with your application workflows, you use that to generate your data model. Then the data is what comes after, right? So it's flipping on the head of the way that we've done it in the relational world. And let's see the leaderboard. Ooh, that tightened it. Oh, well, look at that. All right, so Srini takes the lead, and Kakamiko in second place, and Aki in third. Push, you're right there. You're right there.
You said you weren't playing favorites.
I know, right? It sounds like I am, doesn't it? Okay, last one. What type is used to store both an ID and a timestamp? A time ID, timestamp ID, time UUID, or all the things in one type ID? Boom! Yes, good job. Most of you got time UUID. That is absolutely correct. So there are some cases where you might be able to optimize in a level and combine essentially a UUID and a timestamp. That is a time UUID. I did drop that link, by the way, to the docs in there earlier. And it's also in the README in the GitHub repo as well. Okay, so with that, let's see what happens here in our leaderboard. All right, so Srini took the win. Awesome job. So Srini, Kagamiko, and Pooja. Oh, Pooja ended up in third. Look at that. So make sure to go ahead and reach out. I realize I don't think Jack is here today. So
we can drop his email in there.
Yeah, go ahead and just I'm going to drop Jack's email. And we're going to say jack.fryer@datastacks.com. So if you were one of the 3 winners, one of the top 3 there, go ahead, and I'm dropping it in the YouTube chat, and I'm dropping it in the Discord chat right now. Email Jack Fryer, and we will make sure to get you some swag for winning the quiz.
Awesome. Wonderful. All right. Well, let's keep moving here. Let me know when I'm back on, David.
You are back on, Eric.
Perfect. So what's next? You've gone through this. You spent 2 hours learning Cassandra. What's next? Well, first thing I want to point you guys to, datastacks.com/dev. Tons and tons of resources there. There are links to the community stuff. There are links to all sorts of informational videos, training videos, learning videos. scenarios, classes. I mean, it's all there. Highly recommend you check it out. We've done a lot with Catacoda recently. Anyone who's used that probably knows what it is. I don't know anyone who doesn't like it. Basically a way to do a self-contained course all online, so you actually get to interact with essentially it's like reading a big doc, but you get to do your exercises in line with the documentation. Super, super cool. Been doing a lot there, just trying to expand our content and make it more usable for just everyday developers.
And something also, to point out about the Catacoda piece as well, all of this is free, by the way. All these resources, all the things that we provide for you are free. It's free for you to go and learn. And what's really cool about the Catacoda pieces is, as Eric just explained, when you're going through like the dev site, you'll see that the Catacoda exercises are embedded, right? You can get this like seamless experience. What's really cool is that those exercises are actually launching Cassandra locally. They're doing it all in the cloud. So if you are on, say, laptops maybe that don't have a lot of resources or something like that, you don't have to worry about running any of this locally. You can actually, it's being done in the cloud for you within the experience, right? So it's really, really nice resource, especially for those who might be resource limited on their machines.
Absolutely. Yeah. All right. And then lastly, there's DataStax Academy as well. But a lot of that, again, is just Catacoda is powering a lot of that. So kind of more of the same. Okay. Developer resources, again, DataStax-dev, community.datastax.com. I brought this up at the beginning. I'm bringing it up at the end again. Community is basically where you can get involved. You can actually start conversing with other users, asking questions, figuring things out. Really, really great place to go. Highly, highly recommend you check it out if you have any intention of using Cassandra in any form, whether it's Astra, open source, DataStax Enterprise, whatever. Check out Community. It's a great place to get connected and get your questions answered. Follow us on YouTube and Twitch. Not a lot of people view it on Twitch. YouTube is by far the more popular of the options. Not sure exactly why that is, but feel free to follow us, and you'll get notified when we're going to be doing more events. And then these slides and materials. That GitHub that you guys have all been using today, that's where we're going to keep all of the materials. And feel free to go use it, reference it, share it with your friends, do whatever you want to do. We even take pull requests if you notice typos or things that
absolutely
aren't correct. So that's there as a resource for you guys. All right. With that, we're gonna say thank you. Do we have time? How are we doing on time? Ooh, we are almost right on.
Yeah, right on the button. That's right.
So maybe we can do. Probably don't have time for an AMA, but I would recommend, if you guys do have questions, go to community. We can ask them there, and we can get some participation going on our end in answering some things for you as well. And Discord's the other place to do it.
Yeah, I was going to mention Discord. And always feel free to reach out to us. We're on LinkedIn, we're on social media. Come reach out. Now, a lot of times, as Eric was just saying, depending on the question, I might just point you to community. One of the really cool things about community is we have people from all over the world and in the community who answer questions there. It's not just us personally. Not only that, if you have a longer form question, I actually saw some questions that come up that are definitely longer form that kind of take a little bit more work to respond to, or maybe we want to be able to provide more resources. Community is totally a place to do that.
Or preserve that question for future people who might run into the same thing. We definitely... we're trying to build a database of resources that make your guys' life easier. So, absolutely. All right. Well, I think with that, we're going to call it here. Thank you all so much for coming. Really genuine thank you. It's because of guys like you that I get to have such an awesome job and present and share things that I'm enthusiastic about. Best job in the world is sharing something you love. So, really thank you guys all for showing up. Just super appreciate it. We'll hopefully have more content that's for you guys to consume very, very soon. There's some good stuff on, I think, Spring next week. It's Spring Boot. And then after that, we'll see. So, all right.
All right, everyone. Take care. Thank you so much. We'll see you next time.
Bye.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.